The next talk is Faust in iPlug 2, Creative Coding Audio Plugins by Oliver Larkin.
If anyone can't see the code on the screen, I suggest what you do is log into the live stream. I was doing that earlier. It's much easier to read than this. Okay, so my talk is about integrating Faust with iPlug, which is a plugin framework that allows you to make lots of different formats of plugin from the same code base. And whilst Faust has got all these Faust to VST, Faust to AU, etc. scripts, if you want to make a product and you want to make a professional user interface, Faust doesn't have the kind of functionality for that, and you're going to have to probably make your own architecture file and integrate Faust code with something else, such as iPlug or Juice, which is another probably much more popular plugin framework, but iPlug is a lot freer than Juice. So anyway, audio plugins, we know what they are. There's lots of different formats, and yeah, if you want to make a product and you want to reach a wide audience, you probably want to support multiple formats, and you might have multiple platforms and also multiple architectures to support. When you're doing the GUI, you have to think about all the different APIs for the file system and the windowing and event handling and that kind of thing. So a plugin framework should deal with all of this stuff. Some thoughts about the state of audio plugins in 2018. So these things have been around since the late 90s with VST2, and nowadays things are changing a bit. Thank heavens we don't have to support all these legacy 32-bit APIs and plugin formats such as RTAS and Carbon on Mac. These things were really annoying to have to support in a plugin framework, so those things are kind of disappearing because Apple forces obsolescence and that kind of thing. We've also got lots of high-res screens on our laptops and things like that, so a plugin framework should be able to support that. The threading models are a bit different because of the way that chips have changed. We've got parallelized plugins, and multi-threading is a much bigger concern. There's also a kind of switch to mobile platforms, and we've got this Audio Unit version 3 format, which is getting quite popular on iOS. Lots of plugin companies are now porting their products from VST, from desktop formats to mobile. And the trend is to have distributed plugin formats. So this is where you might have the DSP and the UI in separate processes, so you can't get a pointer to the UI from the DSP part. And there's several formats which can optionally have this, or maybe have to have this. And another trend is that, as with desktop apps, the possibilities of using web technologies inside plugins is becoming more appealing to me anyway. This isn't really a trend. People aren't really doing this out in the wild yet, but myself and my collaborator for these web audio module plugins, we've both been experimenting with using web technologies inside desktop plugins. And I think in a few years' time this is going to be a lot more possible. So iPlug was originally created by the people who make Reaper, and open sourced in 2008, and I've had a fork of it that's probably been the most popular and well-maintained fork. Over the last year I've been updating it, reworking the code base, making it a lot more consistent, and using lots of nice functionality from C++11. I've split up the concept of a plugin and the UI, so you can actually use whatever UI framework you want on top of an iPlug C++ plugin. We've reworked the graphics backend, so you can do hardware accelerated graphics using a library called NanoVG, which is a really, really nice vectorial toolkit for doing drawing. And actually on Mac and iOS, it's using Metal, which is Apple's equivalent to Vulkan, which is a modern GPU technology. So that's all working. I've also updated it so that you can do distributed plugins, and the whole motivation for this really is to support web audio modules, which is a new plugin format for doing VST style plugins on top of web audio, and that's necessitated being able to do distributed plugins. There's a few other things, including what I'm talking about today, which is the Faust support. So I like to use Faust. I've used it for experimental things and kind of research things, but it's a bit of a problem to use it in a product, or combining it with lots of other C++ code is challenging. It involves lots of editing on the command line, and I want to make that process easier. This is kind of what the iPlug folder structure looks like. An iPlug project has three important C++ source code files, and the whole folder structure is quite well controlled so that you can just duplicate a folder and you get all of the right include paths and this kind of thing. And yeah, I don't use CMake. I prefer just to be able people to be able to just drop in, open up an Xcode project or a Visual Studio project or a Linux, run the Linux makefile, and it just works. And this Python script duplicate.py will clone a folder and rename everything. Every occurrence of iPlug effect could be renamed to my new plugin or whatever. So in terms of the Faust support, I have this folder extras, which has got a lot of functionality that you can bring into an iPlug project. They're optional things which don't get included by default. And there's a folder for Faust support, and there's a few different things in there. We've got an architecture file, and we've got an interface called iPlug Faust, and there's also iPlug Faust Gen, and both the architecture file and the iPlug Faust Gen class inherit the iPlug Faust interface. And what this means is that you can use iPlug's Faust support to basically have a DSP block inside your iPlug plugin that alternatively uses the dynamic compiler or the static compiler for Faust. So we'll see in this workthrough how that's going to work. Considering a Faust DSP like this, which is a very simple distortion with a tan-H. So I'm multiplying the incoming signal by a gain factor and piping that into a tan-H. If I have my iPlug effect header file, my C++ interface, I want to include some Faust code, and I can create what I call a Faust block. This links a member variable to a Faust DSP, basically, and it uses a preprocessor macro to do that, so that when we switch from dynamic to static compiled versions, we can completely exclude all the dynamic code path. And there's some arguments to pass into this. You've got a name, which is the way of identifying this particular Faust block. You might have multiple Faust blocks with the same name, and they will link to the same factory in the Faust dynamic compiler. That saves us compiling the same thing twice, basically. But if you want to have two separate instances of that, you want to link them to separate member variables. So the second argument to this preprocessor macro is the name of the member variable. Then we've got the absolute path to the Faust DSP file on disk. I'd like to work out how to do this with a relative path. I haven't quite worked that out yet. And we've then got some arguments. One of those is the oversampling factor, and one is the polyphony count. I haven't actually implemented polyphony yet, but because Faust has this poly DSP class, I should be able to do that soon. In the C++ implementation file, we can initialize the just-in-time compilation, and there's a method to create all the iPlug parameters based on the Faust DSP. There's obviously methods to set the values of the Faust parameters, and you can do that either using a string or an integer for the index. And then you can call a method to actually call the static compiler to generate some C++ code. That's something that you can do manually, but you can also enable a file watcher, which is going to look at this DSP file on the disk, and anytime you modify it, it's going to do the just-in-time compilation, but also call the static compiler to update a header file with all of the C++ in order to compile without the dynamic compiler. So you can integrate that in your process block method, like so. When the sample rate changes, you need to update the Faust DSP, and when a parameter changes, you also need to pass that through. But as you can see, there's very little C++ code here, and this is my real motivation with iPlug. I want to make the amount of code that you have to write to implement a plugin in C++ as small as possible, so that you can focus on the fun stuff, which is the DSP, the UI, and the user interface. Right, so now I'm going to switch to a live demo, and hopefully things don't crash. But I've got a few different things here. So I'm sorry this is extremely small on the screen, but basically I've built this project, and it's got a basic user interface, and I'm running the just-in-time compiler. Let me clear my screen there. Let's make this a bit bigger. Stop. Okay, so here's my Faust code, and here's my C++ code. Have I got some sound? No. Oh, here we go. I can hear it. It's very quiet. Okay. It doesn't matter. That's loud enough. Can people hear a sine wave? Okay. So I can either use my favorite text editor to modify this code. Let's replace that with noise. Or the iPlug Faust support includes a built-in editor, which is based on the curses library, or an emulation of curses, which comes with the Cocos WDL library. So I didn't write this, but if anyone's used Reaper before, it might look a bit familiar because they use it inside Reaper. So that's quite nice if you want an integrated editor inside your DAW. I've written that in C++, but they have a kind of template which I've hacked. It's not quite as nice as editing some of the web-based source code editors, and you actually have to code it in C++. There's not a kind of script file you can edit. Okay, so if I wanted to build a version of this plugin that I could distribute that didn't have any dynamic compilation, when I make the release build, I can just define a Faust, a preprocessor macro, Faust compiled, and that will switch out all of the dynamic compilation, and I'll have quite a small binary that doesn't link to the Faust dynamic compiler, an LLVM. Okay, sorry, there's some more demos now. So in order to promote the kind of creative coding aspect of iPlug, I thought I'd show a few elements of that. So this is a vectorial GUI. The original version of iPlug didn't really support vector graphics. You could only draw lines that are 1 pixel wide, which is a bit rubbish. This is using NanoVG, so it's running with Metal, 60 frames per second, and I've added lots of functionality with C++11, so I've got lambda functions for animations. So when I click this widget, it will run a custom animation. In this case, I'm rotating the whole thing. So another thing to demonstrate is how this can be used on the web. So in each of those plugin project folders, there's a scripts folder, which has got a build script for making a web audio module version of the same plugin. And in a second we should get a web page which looks the same, except for that colourful widget, which I haven't implemented. Anyway, this audio is going through the HDMI, so we can't hear it now. But that's exactly the same UI code, exactly the same DSP, all running inside web audio in the web browser, etc.
So the keyboard is part of iPlug?
Yeah. Enabling this distributed aspect in iPlug plugins has allowed me to do something which I think is quite cool, which is to build a WebSocket server into my desktop plugin binary. And then instead of the web graphics front end speaking to the web audio DSP, you can actually make a remote editor in the web browser. So, get rid of you. I'm running a remote editor in the web browser, and the UI is completely synchronized. There's a messaging system sending updates between either side, so I can play in my DAW or I can play in my web browser. And of course this means you can run it on a tablet in your studio, so you can have a remote interface for your BST plugin running on your iPad and save some screen real estate. And it works quite well across the Wi-Fi network as well. Okay. Yeah. Yeah, so there's a menu in Xcode, and you can choose whichever thing you want to produce, and it's the same C++ code gets compiled. No, it's set up with Visual Studio. There's the beginnings of Linux support, but if anyone would like to help me with that, I'm not really a Linux guy, but I would like to get this working on Linux. And you may have seen, but Kokos have just released Reaper for Linux, which means a lot of the C++ tools that I'm using to do all this stuff is working with GTK and all the Linux libraries. So there's not that much work to get this all running on Linux as well. I just wanted to quickly show an implementation of this which is a bit more practical. So Aaron presented his ambisonic decoder toolkit, and I work a lot with ambisonics, and I've been using his toolkit to make lots of different decoders, but that's a kind of offline process, and you've got all these graphs that come with his decoders, and I wanted to be able to inspect the graphs at the same time as listening to the different decoders to see if the sound kind of matched up to what the graphs was showing me. So by using this Faust, the libfaust compiler, I can just-in-time compile one of his decoders, which are quite complex Faust things, so they take a while to process, but I can do that, and I can display the PNG files in the same folder, which display all the characteristics of the decoder. I can display them at the same time as listening to them, basically. So to conclude, there's quite a few things to do on this. What I've shown you today is not quite ready for prime time. I couldn't give it to someone who wasn't a real techie and expect them not to get lost very quickly. It breaks quite easily. If parameters change in your Faust code, I'm trying to make it so that it doesn't crash the plugin, and it just automatically maps everything back and stuff like that, but that stuff's not so easy. But I want to get it to that stage. I've been doing all of this on Mac, and iPlug has previously worked very well on Windows, so it shouldn't be too hard to get all that stuff working again, but that's going to be a lot of work, unfortunately. Another thing I've updated is I've added loads of documentation to iPlug, which wasn't there before, and some of the APIs are going to change because the names are wrong and things like that. So currently I haven't uploaded it to this GitHub link, which is where it's eventually going to go, because I don't want people to start working on it and for things to change halfway through. But I hope to do that by the end of the year. We have a paper in the Web Audio Conference in September, and I hope by that time I will have something online. But yes, I guess that's me. So if there are any questions.
So, are there any questions? Yeah, many? Okay, let's start with this one.
So, sorry, I suppose something I missed was you still had your slider in your Faust code. So how did you connect that? You just replaced the UI stuff with your stuff, did you, or have you done?
So every H slider or V slider gets registered as a parameter, and yeah, so you have a list of parameters which you can address with integers or the name of the parameter.
Right, that's why you had the string bit where you were given the
Yeah.
name of the gain, right?
Yeah.
Okay. Yeah.
One question concerning WDL. So how far has iPlug 2 gone from that? A lot, I guess.
From the original version.
From the original stuff that shipped with Reaper.
So iPlug was never shipped with Reaper. In 2008, it was part of WDL. Right. And one of the main developers for Reaper made lots of plugins with iPlug. But because they kind of abandoned it, they now recommend to use my version. But yeah, when I was making iPlug 2, I considered stripping out all of the dependency on WDL and replacing it with the STL. But actually, I don't like STL that much, and WDL works, and it's I don't know. It's at a stage now where if someone really wanted to replace it all with STL, they could and remove the dependency on WDL. But yeah.
So all the user interface is done with NanoVG?
It's there's an abstraction of user interface called iGraphics, and that has methods, draw circle, draw square, this kind of thing. And you can either use NanoVG, you can use Lice, which is the Cocos drawing engine, which doesn't really do vector graphics. You can use Cairo. You can use AGG, anti-grain geometry. And these things all have different pros and cons. So NanoVG is GPU based, and OpenGL support is never as consistent as we'd like. Some machines don't necessarily support OpenGL 3, and if you've got a built-in graphics card, it might not work too well. The Metal implementation only works on Mac OS 10.11 or higher, and doesn't work on certain machines. So Cairo is a very good option, but it's a much bigger library, and your binaries end up being a lot bigger. But the idea is that in the dependencies folder, there's scripts to build Cairo for Mac and for Windows. And I'm also going to provide a zip file with static libraries, probably including static libraries or perhaps a dynamic library for Faust, so that someone can use iPlug without building that entire Faust distribution. And same thing for Cairo and all the graphics libraries. So it's meant to be easy for people doing, just getting started making plugins in C++ or for teaching and that kind of thing. So it's not really painful to set it all up.
It's a very impressive project. So a last question maybe, because do we need to have lunch, or is it's optional, right?
Before lunch.
Okay.
So, okay, one more.
All right, one more. Okay, so I'm just thinking about your metal stuff. So you're just implementing a 2D library on top of metal, are you? So you've got some simple shaders that are just handling transformations, and then some simple.
NanoVG does one big shader for the whole.
Oh,
GUI.
okay.
Yeah.
So it should be reasonably quick to port it to Vulkan then, or say, for example.
There's already NanoVG ports to Vulkan, I think, in the BGFX library.
Right,
but
yeah, sure. No, well, I was thinking more because there's I haven't looked at it at all, but I've noticed just recently that Kronos have released the Vulkan on Metal API. I suspect that this would be small enough to actually work. It doesn't get some of the corner cases that might not work. I know that. And so that might be a nice kind of way of finding a portable layer between different platforms. But anyway.
Someone on the iPlug Slack channel has been helping me get it compiling on Windows with OpenGL, but ideally I'd like to do it with Vulkan instead. Yeah.
Right, yeah, it'd be good to look at. All right,
Yeah.
cheers.
Oliver, thanks again. Very impressive project.